Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers. Sitting on the desk today, I've got an old looking amplifier. It's a Sony. I've always wanted to use that catchphrase that used to be knocking about in the 90s. It's a TA-212 integrated stereo amplifier, as they call it, which, well, you think means integrated circuits on the inside. Well, no, there's not, so that's not what it means. One issue is the power button is missing, but the power switch is still in behind the hole here. This is a bit like play school. This I bought from the Glenorchy tip shop on the weekend for $9, parts only. And I've already gone ahead of time and figured out what the actual issue with this is. It is completely dead. It's deader than Elvis. Yes, I'm sorry, it's true.
Yes, it's true. This man has no dick.
And I know why it's dead. The primary of the main transformer is open. So it's getting no power. As to why that primary is open, I don't know. So you'd think, oh yeah, this is a nice looking, Sony amplifier from the probably late 80s. And maybe worth fixing. Well, it would be if it was actually a Japanese Sony. It's not. It's a Chinesium Sony. Well, actually, confusingly made in Taiwan, Republic of China. So, well, it's probably more likely Taiwanese. But either or, it's not really worth anything because it's not a Japanese Sony amplifier. So there's a good look at the rear panel of it, made out of masonite as they often did. And it's a bit warped. It looks like it's gotten wet at some point. So it's got aesthetic issues as well, which would also affect any resale value. But because this is not like the last of the Japanese made amplifiers or anything, it's not really worth anything, and I don't really want to pour a lot of money into it. So there's our various inputs. We have a phono, a tuner, a tape, and a record out. 2 speaker connections, left and right. Speaker impedance 8 to 16 ohms. Caution, before changing the voltage, disconnect the AC power cord. And there's the voltage selector down there. And the cord's been cut off. As we can see here, it's no longer there because I've actually already removed it internally to do some testing. This is actually quite a unique clamp, and I'll show you that when we get on the inside. But the overall build quality on the inside of this thing is atrocious, and you'll understand what I mean when I get the top off and we have a look. So that's the next thing I'm going to do, is pull the top off, and we're going to look at what's inside of it, and then try and figure out why the transformer went bye-bye. So that's what it looks like on the inside. There's the transformer that's problematic. This one's made in Taiwan as well. It doesn't give me any information on what voltage output that is, but I've looked at the service manual to this, and the DC supply rails are plus minus 25 volts, so that would make this a 18018 transformer, and a really inadequate looking heatsink here, just a piece of aluminium. But this is what I mean about the build quality. It's all over the place, and there is not one fuse in sight anywhere in this unit. That's the phono preamp over there. There's not even an AC line fuse, which is very bad. But that's what I meant about the uniqueness of that cable grip clamp. It's got a little grub screw in it that you can actually remove and pull the cable through. And then you change the cable and retighten down the grub screw. A lot easier than those clip things. And near that transistor looks like a burn mark on that insulation washer, which is just a strip of the stuff that those washers, those sill pads you get, are made out of. Just one continuous strip. It's like, why? Just why? There's the main filter caps, and they're only rated at 35 volts, so that gives you an idea of what the supply rails will be. So, as I said, I've already read the service manual, and the supply rails are plus minus 25 volts. So, apart from the dust on the inside of this thing, it's, I suppose, not that badly constructed, but it does scream 80s at me. But we've got transistor's just bent over at weird angles and not straight and all that. And they're using 1 amp diodes by the looks of things. And for the bridge rectifier, so it wouldn't be drawing that much current. So why did this primary on the transformer go open? Well, there's two scenarios, and both are related to each other. The first scenario is, well, simply that this amplifier was just driven too hard, which caused the transformer to overheat, which in turn took out the primary thermal inline fuse, which I'm assuming, this being a standard E-core transformer, would have one, although this was from the 80s, so or either that or the winding's gone open. The second scenario, which is more disastrous, is there's a catastrophic fault with this amplifier, like a shorted output stage, and because there's no external fuse protection in here anywhere, well, it overheated the transformer and took it out on the primary again for the same reason. So I don't know which scenario is correct, but it'd be one or the other. So basically, for all intents and purposes, this transformer is now complete junk, and I won't be able to get another one, not of that style anyway. So what I want to do is I want to inject into the DC side of the bridge rectifier over here a DC supply voltage of plus minus 18 volts, something like that, just to see if there's actually a fault with the amplifier. I've just noticed there's all this brown glue crap in between the filter capacitors there. That could be problematic. Just see if we can get power to this thing. The other issue is the lights for the 2 panel meters up the front here run off of a separate secondary winding of the transformer over here. Really thick current looking wires too, for something that wouldn't really draw that much current. But I don't know if the globes are any good. So even if I did get this to work with another transformer, I'd have the issue of, well, the panel lights. But I'm not going to get too far ahead of myself here. I just want to see if we can get power to this thing from a DC power supply. But first, I want to check these output transistors to make sure that they're not shorted. I can't see if they're destroyed or not. It doesn't look like it. But I'm concerned about that burn mark on the sill pad here. Oh, that stunk. Because if those output transistors are shorted, it's all over for this. So the base is there, collected there. Wrong polarity. Let's try and reverse the polarity. Got a reasonably good junction. Emitter. Good junction. Collector 2 emitter. And that one's not shorted, so that's fine. So we'll just check at the other polarity. It's fine. So I need to get into this transistor, which is next to it, if I can see what I'm doing. So this should be the PNP. If I can get my probes in there, it'd be nice. Let's bend those out the way. Oh yeah, the base to collector on that one doesn't look too good. Neither does the emitter. Ooh. Oh yeah, we got a dead short across the collector and emitter on one of the channels. Ooh yeah, that's bad for this now. I'll try and check the other channel if I can get my meter probes in there. That's base to collector, that is shorted. Or is it my leads? No, it's not my leads, it is shorted. Get on there. Shorted. Base to emitter. Seems okay, but it's rising and going all over the place. Collector to emitter. Seems okay. Base to collector on that transistor is dead. So I'll look at the other transistor on this channel. base to collector. It's low. It could be circuit tolerances, something in the circuit, I don't know. And collector to emitter, oh, nah, these transistors are dead. The output stage is blown up. We've got only one good transistor on this channel that still works. The rest are all shorted for one reason or another. So that's the end of that. I'm not even going to bother hooking up a power supply to it, because it's not worth the effort, because I'd have to like pull the transistors off and replace them, and they're like 2SC devices. And I could probably get away with TIP 41 and 42C respectively if I had any. But again, I don't want to throw any money at this just to, you know, see if it works for a crappily built amplifier in the first place. Yeah, it's not really worth my effort. Yeah, so unfortunately I'm not going to go any further with this. It is definitely a parts only piece of crap. So yeah, that's a shame. I wanted to do a little bit more investigation with this, but yeah, considering it's got a blown up output stage, it's not worth going, because even if I was to replace the transistors with modern equivalents, yeah, I'm going to be spending like, you know, $3 or $4 per device, and there's 4 of them, and that's like $12 that I don't want to spend, and plus the transformer's dead. So I pulled the panel meter globes out just to see what they were, and they're the axial style, like PCB mount ones, with a blue deteriorated like thing on it to make it look blue or green, but I don't know what voltage they're supposed to be. I was hoping they were just like normal incandescent ones that screwed into a holder or something, or were soldered to the board, that you could actually read what voltage they were. It's 2 different sizes. This is a longer one compared to this one, which is shorter. So this one's been replaced at some point. Oh well, yeah. I can kind of tell with the crappy solder work on that. Look at that! Jesus Christ! That is bad. And that was done by a technician? Really? Now it does look to me like they're running in parallel, because we've got one coming in here connected to the 2 sides of each globe, and then another trace coming into here going all the way around to this one. So this would be in this one over here. So this would be in parallel. So if one blows, the other one's still going to work. Question is, do they actually work? Well, I guess we can find out. So in order to do that, I'm going to have to pump DC into it, but we've got a transformer winding across where I want to put the DC supply. So there's going to be very little ohms there, probably about 2 or 3 ohms, and that will look like a dead short to the DC supply, so I'm going to have to remove one of those wires, just so it's not in circuit anymore. Oh, the smell of old solder, that stinks. Damn, man. It's reminiscent of the 80s, when I was pulling TVs apart. Oh, geez, that really reeks. Damn, it's worse than my farts. Now, so the easiest way to do this is I'll connect the power supply across each lead of the globe, or one globe, like so. Make sure it's not shorting on anything. That's plastic there, so yeah, I've got the iris turned right down so you can see it when I turn on the load. Well, we've got one. This one appears to be blown. So I'm going to wind the voltage up. Because I don't know what these run on. because I'm at 9 volts and that's pretty bright. I was wondering if it will run at 12. Are they 12 volt? Yeah, but it's awfully bright. It's probably running at a lower voltage than 12 volts. I'm going to say probably around about the 8 volt mark, 6 volt mark. Otherwise it may be too bright. It's hard to tell, but yeah, definitely that one's blown. And funnily enough, that was the one that was replaced. Okay, typical early 80s PCB drilling. That hole where the wire went is not even drilled in the center. Typical. So I'm just going to put this wire back in here because, well, it no longer needs to be out, and well, I'm not going to go ahead and fix this thing unless somebody in the comments wants me to, or I get enough interest in it. I may look at it, but I'm not going to throw it out. Put it that way. That solder smells a lot better than the one stuff that was on it. So yeah, I'll leave that up to you in the comments. Do I replace the output stage transistors and check other transistors in the circuit, make sure that they're not shorted or anything, and then try applying DC power to it? Or do I just scrap it? Because I'm on the fence at the moment, but I'm on the side of scrapping it because it's just not worth the effort fixing it. There is a removable hatch on the underside of the unit to get to the underside of the board, main board here, so you don't have to actually take the thing out. But yeah, and this seems kind of wank the way this is put in. Yeah, it's putting it at an angle and stressing it. Gee, they really thought about this design when they built the damn thing. Not. Anyway, so yeah, leave your thoughts below, but as far as I'm concerned, this thing's a piece of shit and is not worth even going anywhere into any component level fixing here. Mainly because we've got all these older style capacitors in here, all these grey ones, which probably are LNAR caps or something like that, but they would most definitely all need to be replaced, including this one over here, right in the corner. It looks like its jacket heat shrinking has shrunk, exposing the metal can on top. I'm talking about the one on the left there. Showing their age and on the verge of just like saying, yeah, I'm done with life. I'm going to make you spend more money and replace all of us. So no, I don't think I'm going to be going ahead with repairing this because I don't see the point. But some of you may disagree, some of you may want me to see me, you know, sort of revive this somehow. The globes for the panel meters at the front here might be a little bit more of an issue. I'd have to come up with a different solution to that. Yeah, well, you could probably mount a couple of festoons in there. There might be enough space. I mean, they are really nice looking panel meters too. The one on the right there needs zeroing, but yeah, it just seems a shame. But as I said, the build quality of this is crap, and it's not even a Japanese amplifier, so it's not worth it to me to look at. But you may think differently. Leave your thoughts and comments below, and maybe I'll look at this in the future and maybe get it going. But for now I'm not going to. With the switch cap here for the power switch, I may be able to find something else to fit that if I do get it going, or get a friend of mine to 3D print a new cap. Anyway, I'm going to leave this video here. If you enjoyed it, please remember to go down below, like, comment, subscribe if you haven't done so already. And I hope you enjoyed looking at this old 1980s style electronics with me. And as always, thank you for watching, and I will see you in the next video.
Amp it up, let the music flow. L's got the magic, come and see the show. Experimenting with wires, making sound divine. When things blow up, we just just laugh, that's fine.